Whenever we are learning our oxyacids, I always have a couple of rules that I follow. And I always start off with a chart that looks like this, where I memorize five most common acids that we use in the lab. We've got phosphoric acid, sulfuric acid, carbonic acid, nitric acid, and chloric acid. H3PO4, H2SO4, H2CO3, HNO3, and HClO3. Notice that we've got three hydrogens, two, two, one, one. I try and just sort of memorize those five acids. I call those the oxyacids, and that's because they've got oxygen in their formula, and we know that they're an acid because of the hydrogen as well. So when dissolved in solution, these become aqueous. They will liberate their hydrogen ions, and that's what makes them an acid. From these ic acids, we can create five more acids. And what we do in that case is if we remove an oxygen, we create an us acid. So ic acids can make us acids just by removing one oxygen. The rest of the formula remains the same. So here we have sulfuric acid. If I want to make sulfurous acid, it's H2SO3, just one less oxygen. So that becomes sulfurous acid. You can also use a pH instead of the F for sulfurous acid. We've got carbonous acid, which would be H2CO2. We have nitrous acid, which is HNO2. So you see the trend here? So just by memorizing the first five ic acids, you can make five more us acids by just removing an oxygen. And then we have chlorous acid. Then what we want to do is we want to take a look at how this relates to some of our polyatomic ions. So what you have to know is that all of your ic acids are derived from your eight ions. So what I mean by that is when we look at our periodic table, we have a list of polyatomic ions that we often refer to when we are making our ionic compounds. But now we're going to start to make a correlation here with our oxyacids. So here is phosphate. Notice the formula for phosphate is PO4 with a charge of -3. That 8 ion comes from your ic acid. So if you remove these three hydrogens, because that's how much phosphoric acid has, you end up with phosphate. Or you can think of it this way. If you were to add the charge, so the number of hydrogens matches this charge, I put H3PO4 out front, right? We add the number of hydrogens that matches the charge, you end up with your ic acid. So what you want to realize is that ic acids make 8 ions or vice versa when you think of it in the other direction. When you take a look at sulfuric acid, if you remove the number of hydrogens that sulfuric acid has, that becomes sulfate. Or if you want to make sulfuric acid and you know that sulfate is an ion, look at the number of charge that it has, add that many hydrogens back on, and you get your ic acid. So ic acids make 8 ions or vice versa. Now you can probably note that when you want to make ite ions, so sometimes we have ite ions in our polyatomic chart. So if you take a look here, here's nitrate, here's nitrite, right? Notice that the only difference between an 8 ion and an ite ion is the number of oxygens. The same with our ic acids and our us acids. So we see the charge for nitrate is -1. If I add that many hydrogens back on, you get your ic acid. So that would be nitric acid. If you take a look at your nitrite ion, whatever that charge is, put a hydrogen back on and you get your us acids. So ite ions make us acids. Okay, so let's take a look. If I want to make sulfite, I can either look at my us acid, remove the hydrogens, and that is my charge. That makes sulfite. Or if I know sulfate, just remove an oxygen and it has the same charge. What you want to make note of is if there was no charge, this is called sulfur trioxide. Because we see a charge, this makes it a charged polyatomic ion. So we don't want to confuse the two. If I want to make carbonate, I can look at carbonate and just remove an oxygen and keep the charge. Or I can go back to my us acid and I can see if I remove the hydrogens, however many hydrogens I removed from my us acid will make my ite ion. So this is carbonate. If I want to make nitrite, it is NO2 with a charge of -1. Again, if there was no charge there, that would be nitrogen dioxide. But because we have a charge, this makes this a polyatomic ion, which is much different. This is nitrite. And you can see just by memorizing these first 5 ic acids, you can make 15 more items, okay? Us acids, you remove an oxygen. That's it. So we go from ic to us. If you want to make all of your polyatomic ions, if you start off with your ic acid, the number of hydrogens that you removed becomes the charge, and that becomes an ate ion. If you remove one more oxygen, it becomes an ite ion. Okay, now a couple more things to make note of. You can take a look, and there are some of these acids that will enable you to remove yet another oxygen. So if I go from, let's say I have sulfite, and I want to remove and I want to become SO2 with a charge of -2. Because you removed yet another one, what do you call that? That becomes hyposulfite. So when you remove another oxygen from an ite ion, it becomes hypo. So we put the prefix hypo in front. If we add another oxygen onto something, so let's say that we have nitrate and I add NO4, okay, so, and it still has a charge of -1, so it has one extra, we add the word per. So that would be pernitrate. Okay, we don't come across those as often, but that's something that you want to make note of. So hypo means remove another oxygen, per means add another oxygen, and if ever you see the word bi, that means add hydrogen in between. So if you have carbonate, for instance, here is carbonate ion. Bicarbonate means add a hydrogen back in. That means that the charge is going to change. So it's no longer a -2. We added one hydrogen back in. So that becomes a -1 charge. It's not an acid yet because we haven't got to something that's neutral. So we just call this the bicarbonate ion. Sometimes your polyatomic sheet will refer to it as hydrogen carbonate. So here, hydrogen carbonate, HCO3, or sometimes you'll see it written as bicarbonate instead without the hydrogen. Okay, so there's all of our oxyacids becoming us acids, ate ions, and ite ions.